Area of the triangle. Let the points A, that is x, 0, and B, that is 0, y, form a triangle with origin O on a plane. Then area of triangle AOB is equal to half into base into height, that is half into magnitude of OA into OB, that is half into magnitude of x into y square units. Now let us derive the formula of area of triangle formed by three vertices. Let A, that is x1, y1, and B, that is x2, y2, and C, that is x3, y3 are the vertices of triangle ABC. Draw AP, BQ and CR perpendiculars from A, B and C respectively to the x-axis. Here AB, QP, AP, RC and BQ, RC are trapezia. Therefore, area of triangle ABC equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BQRC, which implies area of triangle is equal to half into BQ plus AP into QP plus half into AP plus CR into PR minus half into BQ plus CR into QR. Since area of trapezium is equal to half into sum of the parallel sides into distance between them, solving this we get area of triangle ABC is equal to half into BQ plus AP into QP plus AP plus CR into PR minus BQ plus CR into QR. Consider this as a equation 1. From the figure, we can notice that BQ is equal to Y2, AP is equal to Y1 and QP is equal to OP minus OQ, that is X1 minus X2. CR is equal to Y3, PR is equal to OR minus OP, that is X3 minus X1. QR is equal to OR minus OQ, that is X3 minus X2. Substitute the above values in equation 1. We get area of triangle is equal to half into Y2 plus Y1 into X1 minus X2 plus Y1 plus Y3 into X3 minus X1 minus Y2 plus Y3 into X3 minus X2. Solving this, we get half into Y2 X1 minus Y2 X2 plus Y1 X1 minus Y1 X2 plus Y1 X3 minus Y1 X1 plus Y3 X3 minus Y3 X1 minus Y2 X3 plus Y2 X2 minus Y3 X3 plus Y3 X2. Further simplification of this will be half into X1 into Y2 minus Y3 plus X2 into Y3 minus Y1 plus X3 into Y1 minus Y2. Finally, area of triangle is equal to half into modulus of X1 into Y2 minus Y3 plus X2 into Y3 minus Y1 plus X3 into Y1 minus Y2 square units. Note that as area cannot be negative, modulus is taken for absolute value.